Here's a solution for day 2, problem 1. Identify the x-intercept and y-intercept for the graph of this linear equation and then graph it. So to get the x-intercept, we can substitute a 0 for the letter y. So if we put a 0 here, 4 times 0 is 0, and 0 subtract 6 is negative 6. So x equals negative 6. That'll be our x-intercept. When we graph that, that means there's going to be a dot on the x-axis at negative 6. And that is right here. Okay, now the y-intercept. To find the y-intercept of a linear equation, we substitute the number 0 in place of x. So we're going to put a 0 right here. That is going to create 0 equals 4y take away 6. Now we can add 6 to both sides of this equation. That will be 6 equals 4y. And then divide both sides of this equation by 4. And so we have y equals 6 divided by 4, which reduces to 3/2, which changes to the mixed number 1 and 1/2. So y equals 1.5. On the y-axis, 1.5 is right here. Drawing through the dots, there's the line. Now, day 2, problem 2. The mass of a compound, m of t, is a function of the time it's been crystallizing, t in seconds. The initial mass is 25 grams, and the rate of change is 10 grams per second. Write a function equation for the situation. So, m of t equals, the mass of the compound was 25 grams to begin with, plus it is increasing 10 grams per second. Let's use the letter t to represent the number of seconds. Here is our function equation. Now in part B, we can evaluate this equation for these various times, 20 and 100 and 250. So m of 20 equals 25 plus 10 times 20. 10 times 20 is 200, plus 25 is 225 grams of this crystal compound. Now m of 100. It's 25 plus 10 times 100. 10 times 100 is 1,000, plus 25 is 1,025 grams of this crystal compound. And finally, m of 250. That's 25 plus 10 times 250. 10 times 250 is 2,500. Add 25 is 2,525 grams of this crystal compound.